how it can be written. So that is unit 1. So what is computer? Computer is kind of device that we all know, that we give some command or we do something on it and we get some output out of it. So you click on some website and something gets popped up, and something like that. So something is happening in that device, you're giving him some command and he's doing some actions on that one, and that actions are nothing but outputs. Okay. So this computer, we have a device. In terms of device, then in that device we have some hardware and also a software. So hardware is nothing but keyboard, yeah, keyboard, cd-rom, yeah, you can say mouse. So many things are there. We are not going into the chip level the hardware. Then software, different softwares are there. So like this website that you're using to access Google Meet is also a software. Then your office, Microsoft Office, all these softwares you use to access this, to talk to this device very easily. Yeah. Then there are, so these many things happens inside this computer, so there has to be some organized structure inside it, otherwise it won't happen. So whenever we go to any organization or any institute, there are different departments. So like admission department is there, student section is there, then personal section is there, then accounts are there, then principal is there. I'm talking about an educational institute. So these type of departments are there or heads are there, so that whenever you have query regarding that particular section or department, you refer to or go to that department only. So similarly, computer has its own organization and it includes these many units. So there is a input unit, output unit, memory unit, arithmetic and logic unit, central processing unit, secondary storage unit. So what we mean by input unit, that I have just told you, that you click something and something gets popped up. So mouse is also your input. Something you write on the Microsoft Office, what we say, in the text editor or anywhere, word, in the word file, that is through keyboard, that is also a input. So keyboard is also input device. Then we have some output unit which works on the output. So something which displays something is done by the output unit. So your monitor is the output unit, then your printer is output unit, you print something and it comes in the form of output. Then control, uh okay, yeah, to control other service devices. So like I would say router and all those things are also output units, because they connect with each other and they control other devices that way, to pass the messages or something like that. So that is also an output unit. So memory unit, it is, this is very important for us, because everything that we will be writing in program will be stored in the form in the memory. So our variables, our values will be accessed from memory. So for that purpose we have this memory unit. Okay, you won't be accessing memory unit directly, but indirectly you, we are not writing programs here, in assembly languages. We are just writing programs here. So in assembly languages you actually have to write the memory locations and registers and all those things, so that we are not dealing with here. So memory unit, we have to store the input information. That is the main purpose of memory. Then arithmetic and logic, that is ALU, to perform the calculations and to make some logical decisions, that we'll discuss afterwards. And then we have central processing unit, so everything will be coordinated by CPU. Okay. Then we have secondary storage. So yeah, here you can have any secondary storage in terms of CDs, or you can have hard disk, and you can have pen drives, and so many things. Okay, so these six logical units we have in every computer. It's not like it was way back it was used and now there are no such units in the machines, computer machines. Yeah, they are always there from the day one. And yeah, the size is reduced, but they are the heart of the any computer organization. Then, okay, this is the architecture. So see, some input is coming here, and this is your central processing unit, CPU. So this input is given to this CPU, and it is converted into output, and which is displayed by some output device. So output device is nothing but a monitor, printer, or something like that. And input devices would be keyboard, mouse, or touch. We have that pane today because touch screens are also there. So that panes are also your digital panes are also the input devices, or digital pad is also your input device. Then accordingly what input you have given, it goes to different department. So कुछ आपने addition दिया है तो यहाँ पे जाएगा, it will perform, it will store, it must have stored the what we say data in the memory. It will fetch it from here, and it will go back to this ALU unit. It will perform it, and it will give it to the output device. So your addition will be displayed here. Okay, likewise. So some controls are there. You're connecting your headphones to your machine. Then again, that will be accessed if it has to be accessed from memory. I think headphone does not have anything in the memory, so it will be directly going back to the output unit, and it will be giving you some output in terms of voice. Okay, so this is a kind of architecture that the computer has. Then we have a computer which consists of,
Ma'am, can you please show the previous slide?
yes please, I'll be sharing these slides with you. Anything that you want to ask till now?
Ma'am, can you please explain the control wala section?
Yeah, see, control section has different what we say functions. So either it is controlling the connection between memory and ALU, because just I have told you that addition of number has to be done here in the arithmetic and logic unit. So but that that will be stored in the memory. So either it is fetching from the memory directly, or these control devices will be giving him this information, and it is accessed by this ALU. So these control devices can also be something which are controlling maybe two or three machines in a network. That way also it has some functionalities. So connection between two three CPUs is also a part of controlling unit. And then the output is given to other machine in the form of maybe commands, or in the form of passing data, or in the form of giving connections to each other, something like that. I'll show you.
Ma'am, can you please explain the J part also of the same?
Which one?
J.
Sorry.
J, J.
This is just what we say, a variable given to this arrow deer. This is nothing to do with anything of this. Like you are going with in what we say, in a particular we label something na, it is something like that. So this J is nothing but something is given from CPU to input unit. So that is just a labeling, nothing to do with the, I mean, functionalities.
Ma'am, but what kind of input can be given by CPU to the input device?
You tell me, is it possible?
Ma'am, for me, no.
Why not? if your keyboard is not working, in that case, won't your CPU give some what we say command or instruction to your input device? Isn't it? It will not work, right?
Huh.
That way, see, there is some arrow towards this, but there is no arrow outside this input what we say input block. You cannot see anything on the input device. Why? Because it is a hardware. You just come to know that yeah, the key is not working because there is nothing displayed on the output device. So that is why something is given to the input, but it is not visible on the input devices. So you have to make assumptions of what went wrong. So that way there is only one arrow towards the input block, but not outside it. Okay, so that way you can uh, this organization work.
Okay,
So
ma'am.
this, yeah. So we have already discussed these things. So I'll go to this in case you want to read out, I'll give you 2 minutes.
Ma'am, what is this ABCD?
These are bulletins. Are you sorry? I think, can you see these arrows? Like you asked ABCD. So this ABCD is related to that. The type of operation that ALU needs to perform is determined by signals from the control unit. So this is one function. So something coming from the control unit is also handled by ALU. Then B, there is a arrow named B, which is coming from input to ALU, which is data can come either from input unit. Then again, it can also come from memory also, which is C. And D, where is D? This data can be given to memory also to store it. Please mute yourself. Somebody's, yeah. Okay. We have already discussed this. Just go through it and then we'll move to next slide. This is just a theory part. You can read it actually, but then it's okay because you might have some queries, and it would be good if I explain it because this is about the fundamentals of programming languages or fundamentals of computer. Okay, the next one is RAM, that random access memory. So everything goes into the RAM, so it has to store some instructions or data. Where can you find the RAM? Can you tell me in which unit?
Memory. Memory unit.
Memory, correct. So RAM is there, so it stores instructions and data as we have discussed, and we this instruction has to be in such a way that that machine will understand it, and sometimes we give instruction that is to be also understood by machine. So if you are writing hello, then that machine should display hello on your output screen. Okay, so lot of processing is happening in the background. So it happens in terms of zeros and ones. So I don't know whether you have learned zeros and ones in till 12th or not, but then zeros and ones is the language understood by machine. So it consists of what we say size or unit, whatever we say. It is of byte and or bits. So byte consists of 8 bits, matlab 8 zeros or ones or combination of zeros and ones. So 8 times you have zeros and ones, then that whole thing will be considered as byte. And bit is, I have told you, 0 and ones. So 0 is considered as off and 1 as on. So it works in that way, but this is not the way that it converts the uh, instructions that we give to machine. It requires compilers, it requires assemblers, it requires interpreters to convert that one. That also we'll be discussing after this. Then F, there is a bar arrow F, which controls the signal, a read write operation. Then G is read write operations. This is also in terms when your computers are connected in the network. And read write, when you're reading something from the memory, you have stored a data in one variable, and after somewhere in the program you want to fetch the value of that variable. That time you want to read, or somewhere you have done the addition of the program, sorry, two numbers, and then you want to store it into the, or write it to the some variable. So that is nothing but a write operation. Also, read write operation, when you're working on the files, when you're writing programs to work on the file, you're writing something into a file. A file in means a word document or any text file. You're writing into the file, or you are reading some text from the file. That is also a read write operation. Then we have a location in memory. Yeah, this you require when you work in the assembly language. So there is a location where from where you want to fetch the data, or you want to store the data. Then input to memory, yeah, and memory to output, that we have discussed. So all these are the what we say, operations of memory unit, or random access memory. Any doubt here?
No, ma'am.
No, ma'am.
Great. Then we have control unit.
का डिफरेंस बताओ एक बार.
Sorry, कौन सा डिफरेंस डियर?
बाइट और बीट का.
डिफरेंस नहीं है डियर. सी, I'll write in the message box. This is the 1 2 3 4, 1 2 3 4 5, sorry, 4. So these are the 8. Can you see zeros and ones I have written in the chat box?
यस मैम.
Huh?
Yes, ma'am.
So these are the bits, 8 bits. So this is a single 1 bit, or let me open one. Okay, give me 1 minute. I'll open one doc file and share with you all, so that you all will understand. Can you see this window of document?
Yes, ma'am.
यस
Yes,
मैम.
ma'am.
Correct. 0 0
Yes,
0
ma'am.
1 1 1 1.
Yes,
Okay.
ma'am.
थोड़ा सा इसका फोन बढ़ा के. ठीक है. Now these are total 8 bits. So this is 1 bit, this is 1 bit, this is, sorry, this is 1 bit, this is 1 bit, again this is 1 bit, 1 bit, 1 bit, 1 bit. Okay, any zeros and ones you write. So this is 1 bit, this is 1 bit, these are 2 bits, these are 2 bits, likewise. So when you have 8 bits with you, and this is your instruction, then this comprises of 1 byte. जैसे आप बोलते हो ना, 1000 ग्राम का कितना होता है? कितना होता है 1000 ग्राम का?
1
kilogram.
kilogram.
1 kg.
It is, yes, it is similar to this one. 8 bits, 8 bits is equal to 1 byte, just like that. Okay.
Ma'am, so pattern should be same like 000.
नो 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 नो, इट चेंजेस डियर। ये तो अभी हमने 8 बिट का बात किया है, अभी हेक्साडेसिमल भी होता है इसमें। इसमें 16 डिजिट्स भी आते हैं। सो दिस विल चेंज अकॉर्डिंगली। चलो थोड़ा बताती हूँ आपको। ये दिस इज 8, दिस इज 4, 2 एंड 1। सो अगर आपको दिस फर्स्ट इज 8, देन इज 4, 2 एंड 1। सो आपको अगर 11 लिखना है तो हाउ यू विल बी रिप्रेजेंटिंग इट इन द बीट्स। सो हमको 8, 4, 2, 1 का पैटर्न कंसिडर करना है। हियर वी हैव 8, 2 which is 10, 8 plus 2 10, and 1 is plus 1 is 11. So how I'll be writing 11 in terms of bits? I'll be writing 1, 0, 1, 1. This is 11. So whichever bits you're adding, you have to write 1 for that one, and whichever you're not considering, like we said, 0 is off, 1 is on, for that bit you have to write 0. So it is always considered in this form. When you consider 16 bit, it starts from 16 here, and this gets shifted here. तो यहाँ से 16 से स्टार्ट होता है। नाउ आई डोंट रिमेम्बर द एग्जैक्ट this thing, 16 and yeah, this sequence I don't remember right now, but when you talk in terms of 16 hexadecimal format, this value changes. So यहाँ पे अगर 16 डिजिट की बात करोगे तो यहाँ पे 00 आएगा, and here you will be having 000 and 1011, because these first 4 digits will be 00 that we are not considering, and after that we want to consider only 8421 to represent 11. So this is how it is considered. So this sequence will change every time. It won't, this is just an example. So when don't know whether DELD is there, or DELD is one subject, digital electronics and logic design. There you we used to do this assembly language programming. So nowadays it is not there for second year, because you have machine learning and all those things included. So otherwise you would have learned these things also, and we used to enter these instructions into the hardware, not using the computer, using the hardware. And then that machine used to give us the output. So if we have written a program for addition of two numbers, then we have to write all the instructions in assembly language, and then we have to feed that instructions into the that hardware, and then we have to check whether it is giving us the correct what we say output or not. So this sequence changes, and this happens in the background. So you need not to worry about this one, because assemblers are there, then compilers are there, interpreters are there, they will be working on this one. So these are for machines only, not for us. For us we have this thing, uh, languages like C hai, Java, C++, Python, so many languages are there. So ठीक है, are we clear?
Ma'am, and in the previous slide, can you please elaborate H and J characters?
H and J.
Sorry, H and I.
H and I. See, H is here. Memory unit is getting input, input from input device. So something coming from input is also storing in the memory. Yes, something
Yes,
you
ma'am.
write on the Word file and you save that file. It is stored in the memory.
Yes, ma'am.
Yeah, and I something there in the memory, you give it to the output block, and it is displayed on the output device. That something is fetched from the memory and displayed on the output device. So maybe opening your Word document is something fetched from your memory and it is displayed on the screen.
Ma'am, but it will happen then only na when we wish to, like when we click on
Yes.
and so
Yes.
enter like.
Yes, when you want to fetch it, that time only it will be giving you access to that one. When that particular file or particular thing is not available in the memory, you get that pop up that file does not exist or something like that, right?
Okay, okay, ma'am. Got it.
Yeah. And in terms of programs, we do it indirectly. That program keeps on accessing these memories indirectly in the background, and that is done by compiler. Sometimes you get compile time errors, so it tries to access those data variables, values, and syntax. It also checks syntaxes also, and if that is not available or accessible from the memory, then you get errors in the program. Okay, that is also an example. An error, somebody is
Yeah, ma'am.
on.
Uh,
Yes.
Ma'am, I actually have a doubt that
Huh.
when we have like a clipboard, so when we copy our data and paste it on the clipboard, so the thing that is on the clipboard, it is stored temporarily. Like after we switch off our laptop, it goes away. So where does it store? Like in the ALU, central, or memory?
It is in the memory. It is in the memory, but it is in the ROM. Okay, because it is temporary.
Okay, ma'am. Yes,
है ना?
ma'am.
So एक minute. I am unmuting you because there is a echo from your side. So that thing is temporary, and that is in the random what we say, or ROM. So that is happening in that cache is also there, but it actually does not go to the cache exactly. So it is just that performing that operation, selecting that text, and after you switch off your computer, it goes off. There is no relation with that one. Okay, any
Okay, ma'am.
great. Okay, okay, control unit. Just I'm giving you 2 minutes. Just read it. This thing we have already discussed. Yeah, shall we go ahead?
Yes, ma'am.
Okay, about common softwares. Yes,
1 second, could you please show the previous slide?
yes, please.
Ma'am, the third point, which is given that in the computer architecture, it fetches an instruction from memory by sending an address G and a read command F to the memory unit.
No,
I
no.
didn't understand.
Dear, this G and F is the label to that arrow.
Ah, could you please explain that?
See, can you see this G and F? Just remember this thing. Okay. If it fetches an instruction from memory by sending an address and read command to the memory unit. So what, as I have talking about assembly language, there you actually have to convert the instruction, and you have to write that code for that instruction and feed it to the hardware that I was talking about. And in that case, this instruction that you have to send in terms of messages, sorry, addresses. Okay, just look at this. Just a second. I'll reopen that Word document. I'll write over there. Is it visible?
Yes, ma'am.
Yes, ma'am.
So there is this instruction, move 12 to A1. Okay. Now this is a instruction for move command. There is a can you unmute, dear?
Sorry, ma'am.
Mute, sorry, mute. Yeah. So to this command move, there is a code. So suppose that I don't remember the exact code. Suppose there is a code 123. Okay. And then there is this 12 and there is this A1. Okay. So for suppose this is a register. So in computer organization subject, you will be learning what is registers, what are different, what we say, uh, st- storage mediums. So for register, suppose there is a 789. Okay, so this is how I have converted my command instruction in the form of addresses. So he computer or that hardware knows what is 123. 123 means move command. 12 is nothing but a number. So there are these particular numbers that are stored or that are dedicated to these particular instructions or particular registers, and though only those are used for that one, other than that one are considered as either data or sorry values or address location. So here you can actually give some address location also, A402. So this is my address location. This is also possible. You can actually give some address location, and that 12 will be stored into this location. Okay. So for that purpose, the statement was the it fetches an instruction from memory by sending an address. So what we are doing, we are sending this address. Okay, we have converted the command and we have generated some code out of it. So this is nothing but the address for that memory unit, and from there it will work. So it will find out what is 123, what is 12, what is 78. It will map accordingly. Now again, this 123, 12, 7, 8, 9 are converted into zeros and ones, that we are not going into that depth. And then again, another thing is to read a command to the memory unit. Okay, so we can read something stored. So suppose I have stored this add 12 comma 13 in some C. Okay, so I want to read C. So when this command is there, read C, this memory unit is used there. So what your control unit is doing, it is fetching that information from the memory unit using that address or using that code, and then it is providing that particular information either to the ALU or either directly to the output device. Am I clear, dear?
Yes, ma'am. Ma'am, it gives the read instruction so that the user is able to read, because we won't be able to read ones and zeros.
Yeah. सी एग्जैक्टली रीड कमांड का मतलब वो नहीं है. रीड इन द सेंस उसके खुद के लिए रीड, मतलब मेमोरी यूनिट और कंट्रोल यूनिट इज रीडिंग द कमांड्स फ्रॉम द मेमोरी यूनिट. Okay, it is fetching that commands. So when there is a read command given by you, yes, he knows that something is to be written, to be read. Or when you do printf पता है सबको, print command पता है. When you say print,
Yes, ma'am.
हाँ, print C. So print C में भी उसको क्या करना पड़ेगा, he has to read this C from the memory unit, and then only it will be able to print the value of C on the output device. Yes, dear, am I clear?
Yes, ma'am. Thank you.
Okay. Yes, I'm going to share this PDF with everyone. Every division will be having the same PPT, so that you all be on the same platform. So we'll be sharing this PPT with all divisions, not only with the E division, or something like that. Okay, so that was about the architecture of your computer. Anything from this slide? Anything you want to get cleared?
Ma'am, if a doubt
Uh-huh.
arises, if a doubt arises anytime later, then how to clear it?
Google Classroom. You have to post anything that you have in your mind, post in the Google Classroom, so that every other person will be reading that thing, and she will be getting answer of that question also. So it's better to share on the Google Classroom. Okay. We'll be communicating through Google Classroom, because mails sometimes I miss, because there are so many mails in every day we receive. So and also when you talk one to one, it's limited up to you only. So let's share with it everyone, because you all are on the same platform. So it's better to have more knowledge and sharing uh, amongst yourself. So share it on the Google Classroom. I don't mind it. Okay, I'll prefer to do that. What do you expect our notes to look like? Okay, dear, I won't be checking your notes. Okay, but you uh, write it down in your own way. I don't know, in your way, maybe in the form of points or something like that. These PPTs वैसे भी share होगी, so I don't think you will need to write down anything. But yes, when during labs, I want you to keep one notebook, so that whatever syntaxes we are telling you, whatever small things we are telling you, just note down it. So whenever, because those things we might not repeat, so it's better that if you make note of it and access it afterwards whenever required. So for that purpose you can keep one notebook. As we are supposed to make notes, no, notes are not supposed to be done. PDF will be sufficient, dear. Do we need to write this all? No, 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 you need not to write it. Okay. So notes are not preferable here. Tutorial होता तो मैं बोलती शायद आपको, but अभी tutorial भी नहीं है, so it's not
Ma'am,
required. हाँ बोलो.
for joining the classroom, it is a needed for code.
Which code?
For the joining the class, they are say having the your classroom code.
Okay, just a thing. Those, because few of you have joined like that. So this is the classroom link. If you haven't received it or you haven't joined it, please click on this link and join the classroom. And there is a link available to in the classroom, as I have told you. It is this is how it looks on my screen. Here there is a meet. Here you can click directly. See, it is visible to you all. So I think it is visible. This type of tab must be there on your dashboard also. So you can directly click on join, and the same link will be accessible to you. Okay. So I won't be sharing the same link every day again and again. You just have to click on it whenever we have our lectures scheduled for that week. So 9 a.m. on the Wednesday. Ma'am, I have installed the classroom app. Yes, dear. Even in the classroom app, you can open this link. And make sure you all have this thing, laptop or something like that, because for lab, I would like you to carry something like that. Yes, Ketki.
Ma'am, for the
Uh,
labs, can we use VS Code instead of Turbo C++?
yes, yes, no problem. Any editor will do.
Okay, ma'am. Thank you.
Okay. So shall we stop here then?
Okay, ma'am.
Okay. Sure. Thank you so much. All are present. 61 are, ma'am, I have text. Yes, yes, desktop
Excuse
is
me,
fine.
ma'am.
Yes.
Ma'am, is there any specific configuration to
No, no, no,
take a
no.
laptop?
No. Because, but take minimum 4 GB and 500 GB.
Okay, okay, ma'am.
Yeah.
Thank you.
Ma'am, I'm click on, but that's saying it's a wrong account.
Okay, Bhakti, I'll send you on the mail. Okay?
Okay, ma'am, thank you.
Yeah. Thank you.
Ma'am, and for further lectures, we have to join through this same link, no?
No, dear, it is only for FPL. Every teacher will be sending you
Yes,
respective.
it's for FPL only, but whenever this lecture
Yes,
happens,
yes. Yes, yes, yes.
okay.
Ma'am,
Thank
is
you.
there any specific software we need to download or something?
No, no,
Ma'am, do we have any microprocessors this year?
no, no. Second year, in second year.
8085 or 8086?
8086.
Okay, ma'am. Thank you.
Yeah. Okay, I have another meeting, so shall I leave now? We'll discuss your doubts in the next class.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
thank
ma'am.
you.
Yes,
Yes,
ma'am.
ma'am.
Thank you,
Thank
ma'am.
you,
Yeah,
ma'am.
thank you.
Yes, ma'am.
Thank you.
Thank
Thank
you,
you.
Bye.
ma'am.
Yes, bye.
Thank you, ma'am.
Yeah, bye.
Thank you, ma'am.
Yes, thank you. Bye bye.